Alright, so we're going to watch the video, and as you're watching, think about these questions. Name one metal family, name one property of metal, and what does alkaline mean? Or alkali.
Alkali metals are soft, silvery white metals that are good conductors of heat and electricity. Lithium, potassium, and sodium are very reactive with water and do not exist free in nature. Alkali means basic, and many sodium compounds are effective as neutralizing acids. For example, sodium hydrogen carbonate can be used to relieve acid indigestion. The strong base sodium hydroxide effectively dissolves fat, grease, and hair in grains. Alkaline earth metals are harder and more dense than the alkali metals. Although magnesium does not react with water, calcium and barium do. Because of their reactivity, these elements do not exist free in nature. Calcium hydroxide, known as flake lime, is used in farming and gardening to neutralize acidic soil. Dissolved calcium and magnesium compounds are commonly the cause of hard water. Insoluble barium sulfate is used to provide contrast during X-raying of the intestinal tract.
Alright, so this is the alkali metal. This is the alkaline earth metal. Okay? What about one property of metal? One property of metal. One thing they demonstrated that the metals could do. And what did they do in the war? Okay. There's 3 other people in the room. One property that they discussed in the video. Okay. They showed that some of the metals, you put them in water, they fizz and produce hydrogen gas. So what happened? A chemical what? Chemical change, a chemical reaction. So they're reactive. Okay? Most of them are shiny, so they have metallic luster. That's a physical property. And alkali means basic. Alright. So go ahead and copy these 3 down. Alright, so if we have a periodic table, this, from left to right across the period becomes less metallic and more metallic. So, what do we have on the left side of the periodic table? Metals and non-metals. Well, it says left to right, we become less metallic. So if going this way becomes less metallic, what do we have to start with? Right. So we're going to have metals over here. We have a stair step over here. So we start with metals over here and become less and less metallic. So what's over here? Non-metal. I'm going to put NM for non-metal. Most reactive metals are on the bottom left in group 1. So this is group 1 over here. They're the most reactive metals, and this one down here that's francium. It's the most reactive metal. The most reactive nonmetals are in the top of group 17. So here, I'm going to go over here for a second. All right. So this is group 18. This is group 17. Group 18 is not reactive at all. They're nonmetals, but they're not reactive at all. Group 17 then is the most reactive nonmetal. And fluorine is the most reactive nonmetal. We just kind of did this. What elements are on the left of the periodic table? What did we say? Metals. What type of elements are on the right? Non-metals. Excellent. Carbon has the atomic number of 6. How many protons does it have? Remember, atomic number is the number of protons. So the atomic number is 6. It has 6 protons. Excellent. So copy these 3. Pause the video. Alright. So valence electrons are in the highest occupied energy level. So if, for example, we had a hydrogen atom, it's got 1 proton, it may or may not have a neutron and 1 electron. So that electron is the outermost electron. That is the valence electron. If we were doing some other element, I'm just going to color in the nucleus. That's the nucleus, and let's say, we had 2 in this shell, and then we had 1 in this outer shell. And that is the valence electron, the outermost electron. The valence electrons are important because they're what's involved in the chemical reaction. So when hydrogen and oxygen bond to make H2O, it's the valence electrons that are actually doing the work. And how many there are important because on the periodic table, they're arranged by number, atomic number, but we can see a pattern in the number of valence electrons. So with that said, we can start looking at how many electrons are in an atom and how many valence electrons there are. One thing you might want to remember and possibly write down is that if the atom is neutral, I think I spelled that wrong. I think it's supposed to be EU. If neutral, if the atom is neutral, then protons equals electrons. So if it has 6 protons, it's going to have 6 electrons, which makes sense because 6 plus negative 6 equals 0, which would be neutral. Half the time when I write neutral or neutron or nucleus, I reverse the U and E. I don't know why. Anybody need much? No, then. Thank you. Alright. So then when I switch over, what we're going to do is we're going to practice.
I'm trying to get this information from my students. The color date,
Middle school is the 3rd for A day at 1:30, and then B B-Day is on the 4th at 1:30.
Okay, thank you.
You're welcome. Right. Really? Okay. So, key things to remember: valence electrons are involved in chemical reactions. Valence electrons are the highest occupied or the outermost electrons. And electrons are, well, the key thing to remember here is that elements in the same group have similar properties. The reason they have similar properties is they have a similar number of valence electrons. All right, so if you start with the nucleus of the atom, here's the nucleus with protons and neutrons in it. The first energy level, the first group of electrons, can hold a maximum number of 2 electrons. So I'm going to put 2 in there. So now that is a full outer shell. Can't hold any more electrons. If there are more electrons, we have to go to the next energy level. Okay? And it can hold 8. 1, 2, 3, 4, 5, 6, 7, 8. Alright, so that's a total of 2 plus 8, that's 10 electrons total so far. If there's more, we go to the third energy level, and it can hold up to 18 electrons. And the farthest, it can actually hold 32 electrons. Okay? Now, when you get to high school chemistry, you're going to learn a slightly different way of thinking about this. That's perfectly fine. Okay? This is what we need to know now. And I've had students before, they always try to figure out, oh, well, you multiply by this, or it's the square root. No, it is what it is. But, okay, and I'm going to be silly here, so Preston, I'm going to need you to remember to be respectful when you laugh at me. Because you're going to laugh at me. You're all going to laugh at me. All right, so, and I'm not trying to call you out. I'm being, okay. All right, 2/8/1832. So, it's 2/8/1832. 2/8/1832. 2/8/1832. 2/8/1832. Okay, right? I'm not saying it's fire. I'm just saying it works. Okay? So I've had a lot of students over the years that remember this because 2/8/1832. And if you want, I'll even throw in a next. 2/8/1832. 2/8/1832. Now that that image and sound is burned into your brain, you'll never forget 2/8/1832.